Let's do an example with a 4 by 4 matrix. So the problem here is this one. Calculate the determinant of this 4 by 4 matrix. So we are going to use the Laplace expansion method. So first of all, in the Laplace expansion method, we had to calculate the minors and cofactors for any row or column. So how do we choose which row or column to calculate? Well, we have to do it intelligently. So notice that in step 2, we are going to multiply each cofactor by the corresponding element in the original matrix A. Okay? So it is always worth choosing a row or column that has a lot of elements equal to 0. Because if the elements are equal to 0, we don't need to calculate the corresponding cofactor. Yeah? Therefore, in this example, if we have a look at the matrix, we see there are several zeros, but there is a very promising column here. Because in this column, almost all of the elements are 0. So let's choose this column to calculate the determinant. Okay? So, the determinant of A is going to be equal to the product of each of the elements of matrix A times the corresponding cofactor. So it's going to be equal to 0 times the cofactor that goes here, which would be C12, plus 0 times the cofactor that goes here, which is going to be C22, plus 2 times the cofactor that goes here, which is C32, plus 0 times the cofactor that goes here, which is 342. Okay, so all these three terms, we won't have to calculate those cofactors because we are multiplying them by 0. So we only need to calculate the cofactor 32. Now, what was the cofactor 32? So remember, the cofactor 32 was equal to minus 1 to the power I plus j, 3 plus 2, times the minor 32. Okay? Now, what's minus 1 to the power 3 plus 2? So you can either calculate it manually or you can do the chessboard pattern. So for the chessboard pattern, remember to start always with a plus on the top left. Yeah, so you start with a plus and then you do the chessboard pattern. So since we are calculating M32, that is the minor corresponding to this element here, and that will have a it will have a negative sign. Yeah, so this will be equal to minus 1. Therefore, we need to calculate minus 2 times the minor 32. Remember that this 2 came from the fact that this element in the original matrix was a 2. Yeah, the minus comes from the chessboard pattern, and then we just need to calculate the minor 32. How do you calculate a minor? Remember, you cross out the corresponding row and the corresponding column, and the minor is equal to the determinant of the smaller matrix that results. So we can write this equals to minus 2 times a determinant of a 3 by 3 matrix, which is the elements that are not crossed out. So it will be 1, 2, minus 1, 0, 2, 1, 3, minus 2, 1. So notice something. We have written the determinant of a 4 by 4 matrix in terms of determinants of a 3 by 3 matrix. So we have reduced by 1 the difficulty of the problem. Now we can keep doing that. So we can reduce this determinant of a 3 by 3 matrix, applying again the Laplace expansion, and we will write it as a sum of determinants of 2 by 2 matrices. So let's do it. Let's choose a row or column in this new matrix here, because we want to calculate the determinant using the Laplace expansion. So choose some row or some column that has as most zeros as possible. So for example, let's choose the second row. Okay, so now we can write this. So always remember to have the minus 2 in front, and now we can write that the determinant of this matrix is equal to 0 times the cofactor of this matrix 2, 1, plus 2 times the cofactor 2, 2, plus 1 times the cofactor 2, 3. So remember, I have gone 0 was the first element with the corresponding cofactor, then 2 was the second element times the corresponding cofactor, and 1 was this element here times the corresponding cofactor. Okay? So we don't have to calculate this one, we only have to calculate these two cofactors, which correspond to these two elements. So remember that the cofactors are just the minors with a different sign. So now we do the chessboard-like pattern, plus, minus, plus, minus, plus, minus, plus, minus, plus. So we are interested in these two. So this one will have a plus sign and this one will have a minus sign. So we can write the determinant of A is equal to minus 2 times, and then we write 2 m22 with a plus sign, because it has a plus sign, minus 1 times m23 with a minus sign, because the corresponding cofactor has a minus sign. Okay? So now we are left with having to calculate these minors, m22 and m23. So m22 is the determinant of the matrix that results when you cross out. So let me copy the matrix here. So if you cross out the second row and second column, you end up with a smaller matrix, yeah? So this will be minus 2 times the determinant of the matrix that results, which is 1 minus 1, 3, 1. Okay? And then minus 1 times the determinant of the matrix that results corresponding to the minor 2, 3. So let me write down the matrix again. So now we are interested on the minor associated to this element. So we cross out this row and we cross out this column. And the 2 by 2 matrix that results is 1, 2, 3, minus 2. Okay? And now we could continue using Laplace expansion with a 2 by 2 matrix, but once you arrive to 2 by 2 determinants, it's very easy to calculate. Remember, you just have to do 1 plus 1 minus 1 plus 3. Yeah, remember that cross trick. So let's write it all. So this will be minus 2 parentheses 2 times 1 plus 1 minus 1 plus 3, and then minus 1 times the determinant, which will be 1 times minus 2 minus 2 times 3. And now we have finished. So the final result, if you do all these additions and multiplications, will be minus 32. Okay, so that will be the determinant of this 4 by 4 matrix using the Laplace expansion method. Notice that if you use the Laplace expansion method on a 3 by 3 matrix, what you get is exactly what we already knew, which is easier to remember just to do the rule of Sarrus. Okay? Okay, thank you very much. Thanks for watching. In the next video, we will study the properties of determinants.